Hello, everyone. Welcome all. Today we have another great topic, and most importantly, another great guest. Jennifer will have a presentation about the microservices. Welcome, Jennifer.
Thank you.
And
Thanks for having me.
I will give you microphone to introduction, and thank you.
I will share everything here. Okay. So I'll queue up some slides here. All right, and I'll talk a little bit, and then we'll dive into code. So I'm here to talk about microservices and Java, and how you can divide up kind of traditional applications into microservices, and what that looks like, and the trade-offs you might get from that. My name is Jennifer Reif. I'll talk a little bit about myself on the next slide to give a little bit of background at least. But my contact information is there in the lower left of this slide, as well as the next slide and the last slide. So if you're curious or want to contact me after, think of questions or want to talk tech or ask me things about Neo4j or about the systems that I built and the code, I'm happy to do that, either right after the session or later down the road, or even months later. So feel free to reach out to me whichever way you are most comfortable. Okay, so a little bit of background on me. I'm a developer and advocate at Neo4j. I like to learn. I like technology. And so then I like to share what I've learned and share that technology with other people. So I do that a lot through writing blog posts, speaking at conferences or meetups such as this. And then I have some other hobbies outside of tech as well. And I really just like to bring the passion that I have for technology and the IT industry into other things in my life as well. So again, contact info is there. I'm happy to talk tech or answer questions about technology in general, or Neo4j or anything along those lines. So first, to really talk about microservices, we need to understand how they came about and why they came about. First off is kind of the previous technical trend, if you will, was to build everything in what they called a monolith. What is this really? It's basically piling usually multiple different functionalities into a single application. Sometimes it's all functionality into a single application. And this can either be intentionally designed that way, or they can kind of grow and take on a mind of their own over time, right? Maybe something that you designed to only have and do a couple of different things, you start adding in, well, let's have it do this. Oh, let's add this new feature. And then all of a sudden it becomes this huge, unwieldy, complicated thing. So if you recognize that image on the right-hand side, you're a fellow nerd like me. I really love Lord of the Rings. And this is a picture of Helm's Deep, the fortress in the Lord of the Rings, The Two Towers. And you can kind of see it's this big, imposing structure. It looks very solid. And the whole premise around this was that the king took his people there to help protect them from an oncoming battle. And his whole thought process was the walls have never been breached. This Helm's Deep is super secure. Nobody will get hurt. Well, not really, but but his people would be saved from harm because Helm's Deep protects them, and it is impenetrable, as he stated. However, if you know the storyline, you've seen the end of the second movie or read the end of the second book, into the third, you'll know that the wall is breached. And you have all of a sudden this massive army and battle taking place inside and outside the walls. So this is kind of the general idea of a monolith. You kind of put protection around this, massive, imposing application. But if something were to happen to that app, if there is a breach, all of a sudden, all of your defenses are gone, and you're left kind of picking up the pieces. or kind of improvising on the fly. So the pros of this type of structure is you have typically a single jar or a single package, and there's less communication. Everything that needs to talk, the functionalities that need to talk or pass values, everything's within a single application. And so that's a lot maybe less cumbersome to pass values or information back and forth, and to share resources. However, the downsides to a monolith is that finding and reusing code can be very, very tricky because, of course, you have this huge code base. Implementing fixes can be very scary because if you touch one thing, it is more likely to impact a bunch of other things because they're all there together, right? And it's easy just to pull in that functionality. Resource consumption is usually heavier because you're dealing with scaling resources based on the entire application and maybe not specific functionality or specific pieces within that app. And then handling failures can be a lot trickier. If something were to go wrong, then the whole system or the whole application is down versus maybe just a piece of it and everything else can continue running. So pros and cons, certainly, to a monolith. But some of the cons is the whole reason why microservices were constructed and architected in the first place. So what are microservices? These are typically small applications for a limited or a single function. So limited use, very minimal capabilities or things that it's going to do. And it only communicates the necessary data. So I have an image here. This is the various battles that took place over Middle Earth, again, from Lord of the Rings. And you can see they're very spread out. You're probably looking at much smaller kind of battle units. And it's all kind of all over the map, right? You don't have this one massive convergence of everything all at once. It kind of takes place here and there. And so you might, accomplish one or two pieces, but you might lose another piece or two, and that in and of itself is not a horrible thing because, again, you're making up for it by having everything spread out. So overall, you're doing much better. Even if one little piece fails, not everything is down and a failure. So the pros here is that they're independent units, so they have very small footprint. They're also very reliable and scalable. So you can create multiple instances of, say, your payment application the week of payroll, for instance. And it also makes things very reliable because, again, if, let's say, the payment system is down, then your benefit system might still be up and running, or maybe your internal company communications would still be up and running, or something else. All of that is out separate, and so therefore impacts to one wouldn't necessarily impact the rest. The downside of microservices is testing and communication between your services can be a lot more cumbersome. As you might imagine, if you have individual little pieces, testing all those, testing them all together and testing the individual components could be a lot trickier and a lot more work involved there. And then communicating between the services. Obviously, they're not sharing maybe containers or packages or classes or anything like that. And so trying to pass data or values in between the services is a little bit maybe trickier, or at least a little bit more work involved there. And you're typically adding more layers and therefore more operations work involved there because you're adding something that the services can communicate. And you're typically adding a layer for like coordination of them. So spinning them all up or spinning them all down, making notes of what's dependent on what and what impacts what, and all that sort of thing. So it does get a little bit more tricky when you think about making the services kind of work together and seamlessly. So just a quick disclaimer. I'm not necessarily advocating for one solution or another. Neither one is going to be a silver bullet. You're going to get simplicity as well as complexity in either solution. So you're going to have some things that are simple and some things that are complex in microservices, and you're going to have some things that are simple and others that are complex in a monolith. Also, when you're dealing with microservices, classification on what qualifies as a microservice architecture vary quite a bit. So depending on who you're talking to or what company you're in, etc. So it varies a lot based on the scope of functionality in the application. So Does it only include one method, or does it have, a few different things that it handles? Does it only handle, one functionality, or maybe one or two or five or six? The discussion between asynchronous communication versus synchronous communication. So am I only communicating between services over REST? That is synchronous protocol. Therefore, if I send a request, it expects a response before it takes the next thing, versus asynchronous. Things like message brokers, Kafka, and those sort of things are asynchronous. And then the level of automation. So how much automation do you have? How many tools do you have in place, or layers do you have in place to spin things up and down or run tests automatically without manual intervention or without operations involvement? And so the level of this kind of depends. Some people say that you only need a microservice to do one very small thing. It needs to communicate asynchronously with other services, and you have to have everything from your dev to your production pipeline built and automated. And others kind of vary that and moderate that a little bit, where it's less strict. So again, depending on what you're working with and how you define your microservices architecture, others may not define it the same way. Okay, so what we're going to do is we're going to build a demo, and we're going to start at a base layer with a MongoDB instance, document database, basically, inside a container, a Docker container that has book data from the Goodreads dataset loaded into it already. This is already going to be up and spinning. I do have some content in the background of how I got this instance up and running, how I loaded the data in, etc. But we don't have enough time to cover all of that, and I want to focus on the application. So I've already got that running. I actually need to spin the container up when I switch over to the demo, but that's already ready to go. So that's my lowest level. That's my database layer. Then I'm going to add an API layer on top of that. So I want a service to be able to communicate with that data stored in the database. So I'm going to create an API service, or service one is what I'm going to call it. And it's going to make calls to the database and return the results of those calls back to service one. Now, this is pretty good. I'm going to create basically a REST API, but I don't necessarily want users to interact directly with that REST API, right? It could be kind of confusing, lots of different endpoints, lots of different maybe segmentation of data and different queries that I might be running. And so I'm going to create a client layer, which is at the top, and that's going to be service 2. And service 2 is going to make specific calls to service 1 that's then going to retrieve data from the database and pass it back up to the client. So I could create, now this seems redundant, maybe I don't need service 2 and this and that, but as you might imagine, as we start building more databases, maybe we have users and user preferences and books that they've read involved. Maybe we'd want to add more API layers to deal with authors, or to deal with publishers, or to deal with users. And so maybe we don't want users to have to interact with those maybe 5, 6, 10, 13 different types of layers. And so we want them to interact only with that client layer in service 2. And service 2 is only going to pull the data that service or that client needs. So for instance, if you're looking at maybe favoriting books, maybe you don't necessarily care about authors or user preferences or other things. And so you're only going to pull that individual piece into service 2. Where you might have more layers, more databases, more APIs underneath that. You can kind of slim down and pick specifics at that client layer of what you need. And then we've got these 3 services now up and running, but it gets kind of cumbersome to spin each one up and down as I'm testing or building or tweaking, adding things, etc. And so what we're going to do is we're going to surround this with a Docker Compose layer, which is basically I create a YAML file and I'm going to outline what my architecture looks like. And then Docker Compose will take care of spinning up, managing, and spinning down all of those instances simultaneously, or together at least. So I'll talk a little bit more about that as we dive into that. But this is kind of the whole goal. We're going to build the service 1 and service 2, and then we're going to create a layer of Docker Compose to manage all of those services together. Okay, so let's dive into the code. Switch over to web page here. So I'm going to start with the Spring Initializer, which is a way that you can create Spring Boot applications. And so I'm dealing with Spring applications. It's what I'm familiar with. It's what I'm used to. You can choose any type of framework or thing that you're comfortable with. That's totally fine to build your applications. This was just where I wanted to start because it's something that I knew well out of the gate. So Spring Initializer, I can basically add in my dependencies and things that I want involved in my application, and it will create the skeleton of my project for me, and then I can add my code in. So we're going to go ahead and do that. So I'm going to leave it with Maven and Java. I'm going to stick with the kind of default or stable version of Spring Boot right now. I'm just going to change this for organization's sake. And then artifact, we'll just call it actually, we're going to call this service 1. We'll leave it as a jar file. Java 11 will stick middle of the road for now. That's okay. And then let's add in our dependencies. So first we need a reactive web. This is going to allow me to create a REST API or a REST interface here. So we're going to start with that. And this will allow me to do it reactively. So if I wanted to maybe bring the REST level up and interact via a message broker, this would allow me to do that asynchronously because reactive supports that. However, I'm going to start just out of the gate using kind of the REST API, which is synchronous communication. But this will at least give us a good start. Okay, so we've added that. And then I also need MongoDB because this, remember, this is our REST API. So this is going to connect to the database layer, which means that it needs to be able to connect to the database. So to do that, I want reactive MongoDB so that, again, we're dealing with potentially support for asynchronous communication. And then lastly, I'm going to tie in Lombok. And that's just going to shortcut some of the boilerplate that I have to write within the application itself. You wouldn't have to use this. And some people have preferences, yes or no, for or against Lombok. But I'm just going to kind of use it for today's demo. And then you can choose at your leisure. Okay, so with those, that's for our service 1. I'm going to generate this and drop it into a demo folder I've created here. And then I'm going to go back and do something very similar, but for service 2. So create service 2. Everything else is going to be the same, except that, remember, service 2 is our client layer. So it actually does not interface with the database directly. It's only going to interface with that service 1. So I can actually remove the MongoDB dependency because I know I don't need it. It's not going to interact with the database directly. And so then I can generate service 2, and I'll put it in that same folder as well. So now, okay, let's go. Let's bring that down. Okay, and then I'll open Finder and go to my downloads. Unzip these 2 things, and we'll start with service 1. I'm going to open this in my IDE, which I'm using IntelliJ today. And I'll open this up, and hopefully I sized up the font and everything in the IDE, so hopefully everything's readable. And then we'll open up, let's just check out our POM first off. So the first thing is everything that we specified is here, so on the Spring Initializer. So I've got my reactive MongoDB dependency in here. I have my WebFlux dependency, which is going to let me create a reactive REST API. And then I have Lombok. And then everything else here, we've got reactive testing and then the Spring Boot testing that's automatically included in projects as well. But nothing crazy, unusual, or fancy here. First thing I want to do is I'm going to have 2 applications, which means that I don't want communication to get confused and maybe kind of routed to the wrong app. So what I want to do is set up a server.port property here that I'm going to route all traffic for this application to port 8081. And then we also need a couple of things in order to connect to the database. So Mongo, if I could type, we're going to use the URI. So MongoDB, and we're going to start with localhost port. The default port for MongoDB is 27017. And then I also have authentication on my database. So I need to actually put in my username and password, super secret password right here. And then I also want to put in the database that it needs to go to, because MongoDB supports multiple databases inside a database management system. And so I need to specify, hey, I want you to route traffic to the Goodreads database on the MongoDB side. Okay, so now that I have set up connection properties, I should be able to route traffic and functionality to my application properly, and then connect to the database as I need to. So with that, let's dive into the actual application layer. Now I'm going to put everything into this single class just for demo purposes. But of course, kind of traditional or clean code writing would have you create separate files for this. But just so you know, today is for demo purposes. I'm going to include it all in one so it's easier to see and read. Okay, so first off, we're going to start with a domain class. So I wouldn't have to write a domain class. I could just map objects and fields back to a map of objects and fields, right? But it gets kind of cumbersome to read those and iterate through those. And so it's just a little bit easier to create a domain object that then I can map. So in our case, MongoDB has that Goodreads data set that I mentioned. So it's books. And so I'm going to create a domain class of book. And then I want to use Lombok in order to shortcut some of the boilerplate I would have to write. So the @data annotation in Lombok creates getters, setters, equals, hash code, and toString. So therefore, I don't have to write any of that boilerplate code. And then I also am going to use the @document annotation, which tells Spring that this is a MongoDB document entity. So MongoDB deals with documents for its data model. And so I'm saying, hey, an object of book is going to map to a document of book inside MongoDB. Now I can go ahead and fill out the member variables. So I need to specify an ID. And so Mongo creates an internal ID, kind of a generated value that it does. And so I'm going to assign that a name of Mongo ID. And then I also have, when I brought in the data set, it had a unique identifier for each book as well. And so I want to capture that as a separate field. And so I'm going to add in book ID. And then there's a couple other fields on the book that I want to capture here. So for instance, the title, the format of the book, like whether it's an ebook or a hardcover, the ISBN and the ISBN 13 for referencing the book worldwide or in country, and then the edition. So if it's a second edition or something like that. Okay, so that creates my object of entities that I'm interested in and want to see. And then I need to create a repository interface, which is basically going to allow me to access methods that I define for querying the database and getting those entities back. So I need an interface, and I'm going to call this book repository. And I'm going to extend the reactive CRUD repository, which basically gives me access to the create, read, update, and delete kind of standard methods. And then I need to define the object that I'm working with, so type book, and then the ID of that object is a type string. And that's actually all I'm going to define in my interface. The reason for this is that Spring out of the box takes methods that a lot of people will implement in pretty much the same way. Things like find all objects, find one by ID, and those sorts of things. Pretty much everybody's going to write the same code to get that data back. And so what Spring has done is created a default implementation for those, definition and implementation, and you can use those right out of the box. And then of course, if you want to customize that or write your own methods, you can absolutely do that. But for now, we're just going to kind of stick with the out of the box stuff to make it easier, hopefully. So next we want to create a controller, which is going to allow us to create that REST API layer that then we can interact with the data from a client side, from outside the app. Okay, so I need a REST controller to tell Spring this is a REST controller class. And then I need a request mapping. So I need to define the endpoint that I'm going to be able to access all of this, all these methods. I'm going to set that up as /db. So remember, our application traffic is on port 8081, and then we can go to /db in order to access these methods. And then I'm going to create a constructor with all arguments included. This is a Lombok annotation. So again, reducing the boilerplate, I don't have to create a constructor with all the arguments. this annotation will actually take care of that for me. Okay, so now I'm going to inject my repository here, book repository. Just going to call that book repository. And again, my constructor is already taken care of, so I can get immediately to mapping out some methods here. Now, I actually want to start with just a kind of a ping, if you will, a ping method. So I want to check that this application is actually live. I had some problems when I did testing, and of course I'm connecting to the database, and there's a lot of potential variable layers that could cause problems when I make calls. So I wanted to kind of eliminate the complexity of a database and eliminate maybe the complexity of other things and just reduce it down to, can I ping this app? Is this application live? And so that's basically what I'm doing here, is saying service 1 is up. And that's it. I'm not making any other calls to anything outside that. And then let's actually define some methods to help us access the data. So let's go to /books. So /gb/books is going to give us all of our books back. So here I want to return a reactive type. And there's two reactive types that you can use. There's either Flux or Mono. Flux is returning one or more objects, expecting one or more objects to come back, where Mono is expecting a 0 or 1 objects to return. So of course, if we're looking at all of our books, we're probably expecting multiple objects, right? So a flux of books is what we expect as the return type here. And then we're going to call this get all books. And then I need to set up my implementation here. So book repository dot find all. Now again, you'll notice I did not define find all in here. It's one of those out of the box methods that Spring provides. Last but not least, I'm going to set up one more method to just retrieve a particular book. And I'm going to do that by passing in the Mongodb as a URL parameter. And so here I'm expecting a single book to come back, right? So I want to expect a mono of book, so 0 or 1 instances to come back. And I'm just going to do get book, and I'm going to pass in, use as a path variable, the string Mongodb. And then book repository dot find by ID, pass in that Mongodb. So again, out of the box method, I didn't have to define this. It's one that Spring kind of gives you out of the box, and then you can customize it if you choose. Okay, so this sets up my service 1 layer really well. And I could go ahead and test it, but let's go ahead on to service 2, and then we'll come back and test the whole thing. So I'll go back to Finder here and open service 2. And I do remember that I need to spin up my database container yet, but we will get to that, no worries. So quick peek at the pom.xml. So we have our WebFlux and Lombok dependencies. But remember, no MongoDB, because we're not interfacing directly with the database in this application. Okay, so let's dive in here. Go to our resources first. The only thing that we need to define here, because we're interacting only with that service 1, is we need to set up traffic for this application to route to a particular port, right? And you'll notice, I don't know if you can see that or not, the default there was port 8080. And even though I would not have to define this, I could just use the out-of-the-box default that Spring kind of has under the covers. I'm actually going to specify it here just for clarity. That way anybody looking back at the code later on can see I'm routing traffic directly here and specifically to this other port for this app. So it's just really a clarifying thing. I actually wouldn't have to define this here because I'm using the default. Okay, for some reason it hasn't finished indexing yet, so hopefully it will in just a second. But as we wait for it, I'll go ahead and get started. So I still want to define a domain class here because I want to be able, again, to map those objects, that maybe the list of objects or kind of those fields or whatever, into something that's a little bit more manageable and easier to iterate over or to work with. So again, I'm going to define this kind of domain class here, but really all I need this time is the @data annotation. So that's going to allow me to do getters and setters so that I can access the fields on this object. But I don't need to do the @document because again, that's specifying that I'm going to MongoDB and I'm mapping that to a MongoDB object, where I'm not interacting with MongoDB, it doesn't really care where the object is coming from. It just knows it's dealing with books. So then I just need to specify the fields that I have. So the Mongo ID, recognizing string, that's no good. Come on. And Maven dependency. Oh my goodness. Okay, well, I may have to reload Maven here. Just a second. But we'll go ahead and get through these fields. So it's the exact same. It should look the exact same as our other object, except that we're just not mapping to the database entity on the back. So we have string title, format, the isBeen 13, and the edition. Like that. Okay. I'm going to go into the POM, open up Maven, and reload Maven. Hopefully it'll fix its brain. Doesn't look like it did. This is service 2. All right, well, 1 second. I may reload this just for grins. Let me go over here too and bring that down. Okay. Close that. And let me just reload this. Okay, and now it works fine. IntelliJ just lost its marbles for a second. Okay, so now we don't need an interface because, again, we're not interacting directly with the database. So all we need is our controller. Oh, and I do see somebody put a note in there that I could go to add the JDK in there, and that would help. So yes, I will. Hopefully we're all solved now, but if that comes back again, that's what we'll do. Okay, so we have a, I'm just going to create a client controller. So I could call this anything I want to, but I'm just going to call it the front end client controller here. So then I need to specify that this is a Spring component. Now this is going to come into importance in just a second when I talk about our bean that we're going to add, and then we'll create basically the same annotations we had before. A REST controller, the request mapping that we're going to call this endpoint goodreads. So this is the endpoint that we want basically users to go to. So remember port 8080 /goodreads is going to get them access to all the information in this class, all the methods here. And then we can do an @allargs constructor, which again is going to create a constructor with all arguments, and that's a Lombok annotation. So now I mentioned that I could create a REST controller and interact via REST services. But what I actually want to do at the client side is maybe I don't want to have synchronous communication. Maybe I want the client to send a request and not have to wait for a response before it does something. So I want to be able to just kind of toss the request out there. And then if the response comes back or it only returns, pieces at a time, that's totally fine. So what I want to do is I want to give the user something in return, but not necessarily wait for a whole big thing if something is going wrong on the back end. So to do that, I'm going to create a separate bean, and I'm going to use the HTTP client. Oh, it's just waiting for me to fill this in. Okay, so we have a web client. So we're going to use Spring Web Client, which allows us to send data back and forth over HTTP protocol. REST protocol is synchronous. It expects a request and a response in return, and it waits for that response, where HTTP tosses the request out there and doesn't necessarily wait for a response coming back. So it's a bit more asynchronous. And so what we're going to do here is we're going to create a client, and we're going to say return web client. Oh, it should just be client dot create. Why isn't it? Oh, client dot web client dot create. There we go. And then put in HTTP, not us, and put in our path to that service 1. So in this case, it's localhost port 8081, right? So it's going to create a bean that then we can reference and use in other classes to access that backend service. So now we can go on down here, and that @component is basically going to bring that bean into this class and let us use that. So that's why I've used that @component annotation here at the top, so I can bring that bean in and utilize that. So now I want to basically bring that in. So private final, and then I'm going to inject the bean. So web client, and I'm just going to call this client for lack of a better name for it. And then we can go ahead and start defining our methods. Again, we have that all-arbs constructor annotation that's going to create a constructor for that bean already for us. We want to do the same thing here. We want to create kind of a live check method to test whether the application is actually up or not. So we're going to call this live check and then return. And we're just going to say service 2 is up. So basically like a hello, I'm alive type of response here. And now we can define a method, and we're just going to define our books endpoint here. So people can go to port 8080/goodreads/books, and we're just going to retrieve all the books for them. And then let's go ahead, and we're expecting a flux of books, and we're just going to call this get books and return the client, and we're going to do a get because we're not writing anything. We're just getting a get response here. .get, and we're going to go to a particular URI. So we've already set up the beginning of the URI with the bean up here, but then we need to define, we have, remember, port 8081/DB/books is going to be our endpoint to get all the books back. And then we're going to retrieve that response, and we're going to convert the body of that response to a flux of book.class. Make sure. Semicolon at the end. Okay. So with that, we're just going to define this single endpoint. Maybe we don't want to define all the endpoints at the client level. We just really want to test this one. So we're going to start with that. And now that we're in good shape here, we can spin up all of our services. So I'm actually going to go out here and switch over to terminal. And let's do I have a container running in the background called Mongo Books, and that's my database layer. And then let's switch over to IntelliJ, and we'll start spinning these services up. So that's service 2. Where is service 1? Oh, I closed it. That's right. Recent. There we go. Service 1. Okay, so let's spin this up. Run. And that might take a second to run. And then once it gets started and looks okay, yep, so far so good, let's go ahead and run our service 2. So again, service 2 is dependent on service 1 running, right? Because if service 1, the REST API layer, is not able to connect the database and is up and running well, then all of a sudden service 2 is not going to be able to ping that and get data back, right? So now with both of our services up and running, we can go back to our terminal layer here, and I'm just going to write a couple of queries. So I'm going to use HTTP port 8081/DB. Now remember, this is going to be our live check method just to make sure that service 1 is up. And indeed, we can actually ping our service and it looks good. Let's do the same thing for service 2 while we're at it, just to make sure, again, both of our services are up and running. And so you can see, okay, service 2 is up. I'll size this up just a little bit more because I feel like the text is a bit small. So now let's start hitting our endpoints. So let's start with the REST API layer. Make sure that that is actually live. So port 8081/DB/books. And it might take a second. It's about 10,000 books that are being stored in the database. So that came back okay. And remember, we also have an endpoint to get a single book back using an ID. So I can actually grab the Mongo ID here of this last one, and we'll just use that as a test. And indeed, we are able to get a single book back. Okay, now that's our REST API layer. What about our client layer? So let's go up to Goodreads/books. And this should, remember, call the find all method on the service 1 layer and get all of our books back. So it's basically the same thing as what we had 2 queries above. And again, might take a second. It's going to return 10,000 books. And you can see everything that was in there is coming back okay. So our service layer is connecting to our client layer in service 2 is connecting to the API layer in service 1, which is then calling the database layer at the bottom and our Mongo instance running below. Now this is all fine, but we're running this all manually locally, right? We're having to spin up and spin down each service independently. What we want to do now is switch over and let Docker Compose handle all of that for us so that we don't have to manually stop and start as I'm doing right now. So with that, I know you all did not come to see me write YAML code. So I kind of created some defaults in here, and then I'll just fill in some of the blanks. But first off, what we need to do is containerize our applications. So service 1 and service 2, we want to put those applications into a container, into a Docker container. So how we're going to do that is I've created a Docker file, and I can open this really quickly just to show you. Oh, never mind. That's not what I wanted. Wrong thing. Oh, that's not what I wanted. There we go. This is what I wanted. I always choose the wrong item. And then I'm going to use Visual Studio Code because I actually like to look at some files in Visual Studio Code better. Okay. So just Docker file. This is for service 1. So what I'm doing is I'm pulling a base image for version 11. It's going to basically put in a JDK layer inside the container as the base level. And then, of course, I'm setting up an author so that people know who to contact, who's supporting or kind of the go-to person for this Docker file for keeping it up to date. And then lastly, I'm going to copy in the jar file that we're going to build for the application, and then expose and run some commands to run that jar file when the container spins up. And so I'm going to do that same thing for both service 1 as well as service 2. So the Docker file, the only difference between the two is the name of the jar file, because obviously you've got a service 1.jar and a service 2.jar. So I'm going to take each of these, again, so we're not doing a whole lot of manual. You watch me write a text file out. I'm just going to copy these existing into the service layers. So basically what this is going to do is it'll allow us to build the Docker image within each service folder here, which is going to grab the jar file and package it all up nice and neatly. Okay. So with that, next I've created a Docker file. I need to actually package up the application, right? And so I'll do that after the YAML file actually. So let's start here. Again, you probably don't want to watch me code YAML. So I've set up kind of the outline of what I have, and then I'll just basically fill in the blanks here. So I have a services and I have a database service, because what I'm going to do, remember I'm running that Mongo books, the Docker container that has my database in it. What I'm actually going to do is let Docker Compose handle that for me too, alongside my service 1 and service 2. So I've got that container in here as DB, and I'm going to call it just DB is the container name. The image I'm going to use, I have a default image sitting out in Docker Hub, and so I'm just going to let it use that. But you could have it build a current folder or use an already existing local image or anything that you choose. This is just what I'm going to do today. And then the port that this is going to run on, this is going to map a host port on my host machine to a container port on the Docker container itself. And I'm going to create a custom network. I talk a little bit more about this in a blog post that hopefully will be published by the end of the week. But I need to create a custom Docker network for all the containers to run on so that they can talk to one another using container name rather than IP address. And so I'm going to create this custom network just called demo for now. I'm also going to mount some volumes here. So what I've done is I have my database and it's already loaded with data. The problem is when I spin up and shut down the database, it's actually going to clean out and wipe all of my data and my scripts and files and everything else that I have loaded in there. So what I'm doing to kind of go around that is I'm going to mount local volumes on my local machine to volumes inside the container so that the data files and flat files and stuff that it already has loaded in, it's going to basically save down to my local machine. And so then when it spins up, it reads the data files from my local drive. So again, not the best solution, but it works for demo purposes at least. And then we have our service 1, and we want our container name to just be service 1. We're actually going to build each time. So I could go out and pull a related image from Docker Hub, but I'm actually just going to build based on the Docker file that I copied into the folder that I showed. So I'm going to build the service 1 folder. And then the image, we're just going to call it service 1. So that way I can reuse it at a later time if I want to, or use it in other Docker files and other Docker Compose situations if I need to. Remember our service 1, we're mapping port 8081. So again, the host port on my host machine to the container port. So I want them to match here. And this service depends on the database being up. So I can actually define some dependencies in my Docker Compose file and make sure that, hey, don't spin up service 1 unless the database service is up and everything looks good there. Now, remember that I set some application properties in my service 1 to connect to the database. We're externalizing that configuration here so that we wouldn't have to necessarily change the application, repackage it up, rebuild the Docker image, and load it up every time. If we externalize that configuration, we can change the configuration without impacting the app itself. So what I'm going to do here is I've got that same Mongodb. And then I need to put in my username and password like I did last time. And then remember, I'm not dealing with localhost anymore because it's going to spin up on its own network. So I can directly interact with the container name, which in our case, remember, was DB for this container. So I can go to DB and then the port of 27017, which is what I've mapped. And then remember the database name is Goodreads on Mongo that I want it to connect to. And then the network is demo, same as what we had our database container running on as well. So it can talk to it. Then we have service 2. So again, very similar to what we had for service 1. I'm going to build the service 2 folder with that Docker file I moved over there. And I'm just going to give it an image name so I can use it later if I need to. And then port is 8080 for this one, because remember we go to port 8080/Goodreads for this data. And it's going to depend on service 1. Because obviously if the API, the REST API layer is not up, then service 2, the client layer, is not really going to be much good. And then I want to set a couple of one environment variable. Now, if you recall, in service 2, we used a web client bean. We created a bean that created a client bean that allowed us to connect to HTTP protocol between the services. Now, remember that we actually hard-coded in the URL for that, and it went to localhost. That's obviously not going to work when we deal with Docker Compose because it's on its own network and it's not going to be localhost host name. So we'll actually come back to this in just one second. But what we'll basically do is we'll create a external configuration that then we can set the host name dynamically. So if we're running it in Docker and it finds this environment variable, then it'll use this. Otherwise, it'll fall back to localhost as a default. So we're going to call the backend host name. Remember, we can reference containers by their name. And so we're going to have it go to service 1, just like we did here with the DB port. The DB port 27017. This will go to service 1 port 8081, right? And then our network, we'll just call it demo. And here, all I've done is defined my custom network. There's no fancy configurations or anything custom we're doing with it. So I've just defined the name here. Okay, now that looks pretty good. Let's quickly switch over to IntelliJ, and I will modify that service 2 for that host name. So if you look up here, see we've hard-coded this in. So what we want to do is use an app value annotation, which is going to allow us to create a dynamic variable here. So first, it'll look for a backend.hostname environment variable. If it does not find that value, and there's a little bit of mismatch, if you notice, between case versus dot and underscore annotation, and that's the difference between environment variable syntax and Spring property syntax. It maps the same, it reads just fine, but the syntax is slightly different there. So it'll look for an environment variable called backend.hostname. If it doesn't find it, it'll set the variable to localhost. And then we're going to call this private string host name, like that. I don't know that I want private on there. But anyway, so we've set string host name, and then I want to put the host name here, like that, in the middle. So therefore, sorry, I had to sneeze. Therefore, it'll go in, it'll set that host name variable first. If it finds the environment variable, it'll use the value of that. Otherwise, it uses localhost, and then it'll insert that value into the URL and call that dynamically depending on the environment we're dealing with. So with that, now we've saved that, and I can switch over, and we've got our Docker Compose YAML file all ready to go. What we need to do, though, is jump into the service one layer, and we're just going to package up our applications into a jar file. The way that I'm doing that, there's a few different ways you can go about it. I'm just going to run a Maven clean package, which will kind of clean out anything that might be sitting out there and then package everything up into a jar file for me. I can't actually verify that this works, and I'll show that to you when I get done with the other one as well. But then hop over to Service 2 and do the same thing here. So bundle up Service 2 and package that application. And again, you could actually create a build pipeline to do all of these steps for you. I just haven't gotten to that level of automation at this point. I like to start kind of at a base level and then work my way up in complexity. So let's switch over and I'll show you how it did this. Bring this down so it's a little bit more visible. So what we should see is in the target folder, we should see a .jar file. And as you can see right here, service2.jar. So it created this jar file for us when I ran that Maven clean package. The same should exist for service 1 here. If I scroll down and look in target, and indeed, we have a jar file there. So that's what that Docker file is going to grab. It's going to grab the jar file from the target directory and package that up inside the container. So now what I should be able to do is go back to my terminal, and I've got everything in order. It's going to build my Docker files and my Docker containers because I specified it to do that on demand inside my Docker Compose.yaml. And so now all I should need to do is Docker Compose up, and I'm going to detach this, basically run it in the background so that all of the log stuff isn't coming to my shell here. And then I wouldn't necessarily have to define the -- build each time, but basically if I need to run it again because I've forgotten something, this will make sure that it builds the Docker containers each time I run this command. So it should spin up, hopefully, all of my, and you can see it's building the Docker images, and that's what all this kind of output is doing. And so it might take a second, and then hopefully it'll spin up each one of those containers as a service. And then I can verify that all those containers are running. Oh, that's right. I forgot to stop my Mongo book. So it says, hey, you have already something that's conflicting. So let's try to do this. And this is why I need that -- build, because it'll basically kind of quickly rebuild that. All right, so you can see it started the database. It started service 1, started service 2. If I run Docker PS, we can see that all 3 services are up and running. I know it's a little bit difficult to see with the amount of zoom I put on this. But we have service 2 here. We have service 1. And then we have our DB service here, which is using that Docker Hub image as its base. Okay, so we have all of our containers up and running. Let's actually check that we can hit our endpoint still. So I'm going to go open a new tab just for cleanliness here, and then do HTTP. Let's check to make sure our applications are up. So again, our live check on our service 1, which is on port 8081. And sure enough, that app is coming back. So again, it's running inside a container, inside a little separate Docker network, and we're still able to ping that application. That's looking good. And then /goodreads, service 2 is up. So that looks good. Now let's hit our endpoint. So again, I like to check backend first. So check db/books, and this should return all of our books. Again, this is the REST layer. Your users or your clients wouldn't interact with this. I just like to check each each kind of level as we move up the stack and make sure that everything's working. And we can pull this Mongo ID again and check, okay, all of our endpoints are up and running in service 1. So now let's check service 2. And remember, we only defined /books here. And so this should pull all of our books back at the client layer. So indeed, everything is working. Our database is up and running because service 1 is able to connect to that and pull data from MongoDB. And then our service 2 is up and running because it's able to connect to service 1, which then connects to the database and on the bottom, and pulls that data back for the client layer, depending on their needs and what you want to customize for them. And then we've created Docker Compose that is managing all of this at once. It spun all of the systems up. All I had to write was a single command, and it ran all of that together. And I can actually specify a Docker Compose down to spin all of the services down and remove all of them. So it cleans it out so that I get a clean run every time. And if I run a Docker PS, you'll see there are no containers running now. So I did all of that with a single Docker Compose command, spun them all up and spun them all back down. All right, let's head back over and we'll run just a couple more slides. So what could we do past this point? We've only covered just a few things, and maybe some of you feel like this is super base level, or maybe some of you feel this is already really complex, but there's lots more opportunities for things that we could do and things we could add here. So we could add more different types of databases, so create a polyglot environment. We could deal with messaging systems, things like Kafka, message brokers, RabbitMQ, and so on. We could add orchestration layers. So we talked a little bit about that using Docker Compose, but Kubernetes is kind of one level up, I think, from that. It seems like it's a little bit more complex, but it does handle a lot of your kind of business or very big systems. It seems to do very well there. So we could talk a little bit about Kubernetes and add that in. We didn't even touch anything on unit and integration testing for microservices and how to go about that. Talking about scaling and monitoring. So things like tool suites for handling. Maybe we need to size up, again, our payroll application during certain weeks, or maybe during the Christmas season, we want to make sure our order and shipping system is handling load, etc. And then we haven't talked deployment either. Everything that we've done has been deployed locally. We could deploy to the cloud. We could deploy to a separate server. We could deploy on various other systems as well, which we did not go into. But there's lots more opportunities for kind of exploring new and more complicated things here. So if you want to review everything we did today, I have an overview project there on the first bullet. That's kind of my meta repo, if you will. What we covered and talked about today was the level 5 code link that's going to be there. But you're welcome to go back and look at all the various levels. If you want to review some of the things I've done before in this kind of general space, you're welcome to do that. I've covered all of this information in my blog, which is there in the second link. And I have the blog post that should be coming out for the information that we covered today. That should be coming hopefully by the end of the week. So keep an eye out for that. And then I'll continue building kind of more complexity into this project as I go along. So keep your eyes peeled if you're interested there. And then if you want to learn a little bit more about Neo4j, what my company does, and how to work with a graph database, that last link, you can go out and create a free instance, free cloud instance as Neo4j hosted, and play with data and interact with the graph database there. So again, my contact information is there. Feel free to ask questions. I'm happy to stick around for a few minutes. And then if you think of something else later after the meeting ends, feel free to reach out to me. Thank you so much for coming, and I hope to chat with you here in a couple of minutes.
Hello, Jennifer. Thank you for this great presentation. It was really great. I really love the live coding section, and I believe the people also loved it.
That's my favorite part too.
Yeah. And if you have time, I believe we have 1 or 2 questions from the chat, and I believe that our host will help us to show the questions on the YouTube chat, but I can read it also. Could you please compare the monolith and microservice architectures in terms of the O&M, which I believe means the operation and maintenance, and cloud costs?
Okay, so that I think is probably going to depend on the types of databases and systems and kind of cloud providers. I am sure I have not directly compared costs with cloud providers, but I am sure there are some that are more expensive than others. And I know that depending on the way you store your data, you may have more storage costs in certain databases than you do in others. So I think it really kind of depends on your system and the complexity level. If you're looking at microservices as a way to save existing costs with monolithic applications, I think what I would do is kind of maybe create one small piece of your monolith as microservices and start there and see, okay, have we kind of saved more cost by reducing this piece to microservices over what we would have had if we had it in with the monolith, and kind of evaluate based on that whether you're actually saving anything or not. And again, microservices are going to create more operations costs and more maybe integration or testing costs. And so that will kind of depend how critical is the application. If it's down, what are you losing and those sorts of resources. So I think it's really going to be super dependent on your application and your use case and the cloud you're choosing and how critical that application is to your system. So that one's a tough one to answer. Sorry, I couldn't be more helpful on that.
Thank you. Thank you for the answer. The other question actually is about, I believe, the REST template. The question is, can I use the REST template with async behavior? As far as I know, you can use the web client with async behavior, but do you want to answer this question?
Yeah, I think you're right. I think REST is going to assume REST protocol, which means that it'll create synchronous communication. If you want to go asynchronous communication, you can use things like HTTP, which is basically HTTP over REST. If you look up that Spring web client, it's doing HTTP protocol, but it is over REST, which is why I could kind of get away with bridging that gap a little bit like that. If you want to go completely asynchronous, that's where you talk about things like message brokers. So I think it really kind of depends on the comfort level. I don't think you can use REST template completely asynchronously.
Thank you. And I believe our last question is about Neo4j. The question is, what is the role of the Neo4j in the microservices?
Yes. So I did not cover Neo4j really today. And so it just wasn't enough time in the day. But Neo4j basically could be part of that polyglot aspect. So for instance, you have some data that works really well in like MongoDB. Our book data actually works really well in MongoDB. But maybe when we start talking about recommendations based on what books users have read or maybe their friends have read, you're talking about a lot of relationships, a lot of joins, a lot of connections between your data. And that's where Neo4j handles things really well. So maybe you'd want to put your book data inside MongoDB, but then your users and their history of things that they've read or things that they really like, and maybe their friends' preferences, you might want to store that bit of data in Neo4j, where it really makes those relationships and those kind of multi-data connections much easier to see. And so then you could use something like a message broker or even data ingestion procedures to pass that related or connected data over to Neo4j, and then use that in a user preferences service or maybe an analytics service or something like that. So you would keep that client book layer for just people looking for books. And then maybe you would create another REST API and another database layer, and maybe another client layer for somebody to use elsewhere. So you're able to kind of break that apart and use Neo4j as either, and you could dump everything into it if you so chose, but you wouldn't have to. You could just use it for the things that it does really, really well, and then use other data stores for the things that they do well.
Thank you. I think that was our last question. And thank you for the great presentation, and thank you all for joining our event. Hope you we will see you soon in our next events. And please check Jennifer's blog post for detailed information. And I believe you will find lots of detailed information at here. So thank you all. Thank you, Jennifer, for joining us.
Thanks for having me.
Thank you.